Hey there, Kristen Rossler here to talk about the GFP Transformation Lab. It's not too bad. It's actually kind of shockingly easy. It's just you have to know kind of what to do. In my week 9 or 10 folder, depending on which week you're doing it, there should be a little overview that says week 9 or week 10 quick notes PDF. And so this is just a little thing I made up that kind of helps one to see all the different steps quite quickly, because when you look at the protocol, it's not always intuitive. Anywho, what they're going to do to start off with is each lab group is going to label 2 tubes. One, again, try to make sure that they use the Sharpie on the top and on the side, and they're going to label one plus PGLO and the other one minus PGLO. So the minus PGLO is obviously the negative control that's not going to have the plasmid transforming the bacteria, whereas the plus PGLO will. And so what we're going to do is we're going to take both of those tubes. We're going to add 250 microliters of calcium chloride into each, and then you're going to stick them on ice. All right, and what the calcium chloride is going to do, you probably know, is going to poke holes in the membrane of the bacterial cells in the cell wall. So it kind of pokes these little tiny microscopic pores, and we keep it on ice in order to make sure that the size of the pores stays small, right? So that the cells don't really die, but also so that we want to keep it compressed. Hopefully that makes sense. By keeping the temperature down, right, it all works. Then what you're going to do is you're going to add a sterile loop of E. coli here. That's step 3. I apologize that I kind of put them out of order. So E. coli will have been grown up prior to your teaching the lab. Tracy usually has them. Sometimes she leaves them out. We leave them out at room temperature over the weekend for the Monday labs, but usually for the Tuesday labs and the Wednesday labs, etc., they will have been grown up overnight so that they're in log phase. All right, so it usually works nicely. The students just need to take a little schmear, obviously not too much, onto their sterile loops. You might want to remind them how to use a sterile loop because they haven't. They will have the little like Quidditch circles, of course, that are in a bag. We want to remind them, of course, to open and touch the loops from the handle instead of opening them up at the loop side. Anywho, have them just grab a little bit of the bacteria, and then they're going to swivel it, just swivel into each of the different test tubes. There's, again, a gazillion bacteria that fall off into each. All right, and so after that point, then they're going to go ahead and, again, keep them on ice during this process. So they'll add it into the plus PGLO tube and the minus PGLO tube on ice. Now, while it's still on ice, they're going to add 10 microliters of the plus PGLO plasmid that Tracy will make sure you have available into the plus PGLO tube. Sometimes I do it, so I just literally go around with a pipette, a micropipette, and put the 10 microliters into the plus PGLO tube. Sometimes I just don't want any contamination, really, of the stock plasmid, so I just do that and allow them, but you can have them do it if you want, but it's just they often mess that up. So now and then they'll again keep them on ice, and so at that point you're supposed to let them sit on ice, both of the tubes, for 10 minutes. All right, so after that 10 minutes is over, you're going to have one person from each of the groups probably come up to the heat block that you have set up for 42 degrees Celsius. All right, and here we're going to heat shock them very rapidly for just 50 seconds exactly, and then put them back on ice immediately. You probably know that the change of temperature is going to cause a change in the volume of the cell quite quickly and a change of pressure. You can go over the PV equals nRT formula and explain to them why the heat shock is so effective at kind of causing, again, those little microscopic pores that we previously had. Here I'll just draw out in case you are haven't done this as much. All right, so when they're on ice, again, the calcium chloride, let me pull back a little bit, has poked little microscopic pores into the membrane of the cell membrane in the cell wall. All right, but they're kept quite small. We have the plus PGLO plasmid that we've added to the surrounding calcium chloride solution, right? So we've got the little plasmid, right? And so what we're going to do, of course, is heat shock it. So when we heat shock That rapid change in heat is of course going to cause the cell membrane and the cell wall to expand. So they're going to open up, those pores are going to become a little bit more large. Excuse me. Oh, this is so poor quality, I apologize. And then we heat shock them for 50 seconds, so it opens up. The cell gets kind of distended, and then we're rapidly going to stick it back on ice. So what happens in that rapid change from going from a really large size with big pores to a very small size back again is that there's a change in pressure. I kind of tell them it's similar to when we open and close the door actually in our lab, right? You can feel that the change of pressure, there's like an influx of air sometimes when we change, open and close that door. And that opening and closing of the door, that change in pressure, differential pressure on both sides of the membrane, is going to cause that plasmid to be sucked into the competent cell that we've made of E. coli. So now hopefully your plasmid has entered or been transformed into the E. coli cell that we had. So it's not too bad. At that point, what we want to do, so hopefully again, after the heat shock, we want to make sure it's very quick. We want to make sure that it's only 50 seconds and put them back on ice. And then as close, as rapidly as you can, we're going to add 250 microliters of LB so into each of those tubes. So Tracy usually has it prepared. It's better if you have the LB a little bit warmed up, right? So sometimes if I have my act together, I'll stick them in one of the incubators ahead of time, just so that it can help to kind of jumpstart the growth of the bacteria. All right, so you're going to add 250 microliters of that LB to each tube, and then you're going to let them sit at room temperature for about 10 minutes. All right, and yeah, so that's pretty straightforward. Then what we're going to do is we're going to plate our 250 microliters worth of LB solution now, 100 microliters of each of those solutions onto, there's 4 different plates in totality. So the first plate is going to be our negative control, right? So this one is just going to be LB, medium without any antibiotic resistance selection. And onto that plate, again, you're going to need to explain to them how to plate. They haven't used the cute little spreaders, the little hockey sticks, as I call them, before. So you want to go over again kind of sterile technique and how E. coli love growing on these little plates. And so we add 100 microliters to the top, of course, of the plate, spread it, and then have them label them and flip them back over. All right, so. And then they're going to do the same thing so that's with minus PGLO test tube. Then they're going to do the same thing on a selectable media that contains now ampicillin, because our plasmid, right, contains the ampicillin-resistant gene, so that should work pretty well. And then the final 2 plates are just the LB amp and the LB amp arabinose. And again, you're going to add 100 microliters of the plus PGLO to each of those tubes. So we go over quite in depthly like what we expect to happen, and why it is, of course, that why do we even do this negative control? And that's just to make sure, of course, that the bacteria are growing. So we should see quite a lot of bacteria on that first plate. And we do this plate also as a control, the LB amp plate, in the minus PGLO transformants. And of course there we should see no growth, right? And that of course is telling us that the ampicillin is selecting. So this one's just a negative control for bacteria, or just a control to make sure that the bacteria are growing. This is a control to make sure our ampicillin is actually selecting for the plasmid. And then here, of course, we should see only bacteria with the plasmid growing, because of course there's ampicillin, and that is found in the plasmid, ampicillin resistance rather. And then finally we have the LB amp plates plus arabinose. And of course what arabinose is going to do is going to drive the production of the GFP transformant, the GFP plasmid. So again, the gene, the plasmid has a arabinose gene unit, right? So it allows it to survive on arabinose and metabolize the arabinose, and when it does so, of course, it's going to fluoresce. So these are the only ones that should be green right here at the end. Anyway, so of course none of these should be green, and this one should be green when we run it out on a UV light the preceding week. proceeding week. I guess that'll be after Thanksgiving. So once you have each group's 4 plates, make sure they're labeled, right? So they're labeled, again, just like this: LB minus PGLO, LB amp minus PGLO, LB amp plus PGLO, and LB amp arabinose plus PGLO. And then make sure they have their lab, maybe initials or group's number initials on it. I tend to tape them together and flip them upside down and stick them into the incubators that are over here in the back corner. Tracy or myself will move them over into the refrigerator so that we can look at them following, whenever we have our next lab session. Yeah, anyway, so hopefully that helps, and feel free to reach out if you have any questions.